Okay, so good evening everyone and welcome to this session. This is the session 5 of this differential equation and I hope that all of you are doing good. So in this session we will discuss about the uh, equation which are reducible to linear form by substitution method. Then we will also discuss the Bernoulli trials and then orthogonal trajectories and applications of the first order differential equation. Okay, probably this will be the last topic of, or we can say last session on this chapter, and after this we will start a new chapter. Okay, so let's start. So the in the last class we have discussed equations which are reducible to the homogeneous form, and then we discussed exact differential form equations, and lastly we discussed first order linear differential equation, in which we studied this form dy by dx plus p of y is equal to q. Okay, and this q and p both are the function of x, right? And in this case, if the differential equation is in this format, then we were saying that uh, we can find the solution by finding out the integrating factor. So first we have to find out the integrating factor, and that integrating factor we can find out by the e to the power pdx. Okay, and the solution was given by y into integrating factor is equal to uh, integration of q into integrating factor into dx and plus some constant that will be getting after doing the integration. So this was the final solution for that first order linear differential equation. Okay, so in this class we will discuss all these topics as I already told you: equation reducible to linear form by substitution, then by Bernoulli trials, then orthogonal trajectories, and the application part. Okay, so let's start with the first of all recap of what we have studied. As I already told you that first order linear differential equation is in this format: p of x y dy by dx plus p of x y is equal to q of x, and in this case integrating factor you will be getting e to the power p dx. Px dx means p is the function of x, and then when you multiply this on the both side, then you will be getting the final solution which is written in this final format. Okay, this we have already studied. Now we'll understand some question on the basis of this topic. So you can see the first question is they have been asked. It has been asked in the email 2019. So it was saying ki if cos x dy by dx minus y sin x is equal to 6x, where this x is belonging to 0 to pi by 2, and one condition is given. Okay, you can see that this condition is given: y of acha, they're actually asking to find out y of pi by 3, and then they're asking to find out the y of pi by 6 also. Okay, so let's solve this question. So what can we do? Any student can give me the hint. What can we do in this part? I think there is an issue in this. There should be y of pi, but yes, tell me. But the problem is that how will you find out the c value? This is the problem. C value, the constant you will be getting after doing the integration. How will we find? Look at the conditions, boundary conditions they have been given. I think there is an error in this part. Can you see that? They are asking both to find. However, one of them should have been given a value. है ना? So you can take this as 0. So take here y of pi by 3 is given as 0. This is an error in this question. Okay, maybe the printing mistake. All right. Yeah, now I think it can be done. Yes, tell me. You were saying something. Tell me. Hmm. Correct. Correct, correct, correct. This is the simple only, right? So we will do one thing. Just first of all, I'm writing the question: cos x into dy by dx minus y into sin x is equal to 6x is given. We will divide by cos x on the both side. Cos x on both side. So when we divide this, we will be getting dy by dx minus this will become y tan x and is equal to 6 into x by cos x means you will be getting sec x. Okay, 1 by cos x, I'm writing it as a sec x. So definitely this is again in the linear differential equation format which we have studied. So you can write the given equation is the linear differential equation. LDE stands for linear differential equation in the form of dy by dx plus p of x whole y means p of x into y is equal to q of x. Okay, so from here when you compare this you will be getting px as minus 10x. Okay, just don't confuse, we have to take the coefficient of 10x, and when the negative sign is there, do involve that negative sign also, because a lot of students do the mistake here. Then qx will become what? 6x into sec x. Okay, now what is the first task? To find out the integrating factor. To find out the integrating factor, so what is the integrating factor value? We will be getting e to the power p of x into dx is equal to e to the power minus of 10x into dx. So we will be getting here, what is the integration of 10x? It is ln, we can take ln sec x. Okay, so negative sign is outside, ln sec x. And when you take this negative sign in the power of sec x, okay, because you know the formula, let me write on the next page. Let's go to the next page. So we are getting integrating factor e to the power minus ln sec x, which can be further written as e to the power ln of sec x to the power minus 1, right? And you know that we can write this as 1 by sec x, and 1 by sec x is nothing but simply cos x. So simply we can write ln of cos x. Okay, and ln you know already, it is nothing but base e. So the final answer is only cos x. So integrating factor value we will be getting cos x only. Is that clear? Okay. Now let's write the solution of this. So solution is y into integrating factor is equal to integration of q of x into integrating factor into dx and plus c. So y into integrating factor is cos x is equal to q of x was 6x into sec x, and integrating factor is given as cos x into dx plus c. And you know that sec x and cos x, they are reciprocal of each other, so they will be cancelled out, and we will be getting here integration of 6x dx, which is nothing but x square by 2. So can I say that it will become 3x square plus c directly? Okay, so this is the equation we are getting. This is the equation we are getting. Now the conditions are given. Given conditions, y of pi by 3 was given as 0. So it means that at x is equal to pi by 3, y is equal to 0. So let's put that value. Let's put that value. So we will be let's say this is equation 1. Put in equation 1. Put in equation 1. So now we'll be getting 0 into cos pi by 3. It will not make any sense. It will be 0 only. 3 times of pi by 3 whole square. Right? And plus c. So it will become pi square by 3 with negative sign. C value will be minus pi square by 3. This will the value. Okay, is that clear? Everyone is getting this constant? So finally I will say that equation will become now y of cos x is equal to 3 of x square and minus pi square by 3. C value actually we have written. Okay. Now we have been asked to find out the at x is equal to pi by 6 what is the value of y. So let's say this is equation 2. So put x is equal to pi by 6, then you will be getting the value of y. Okay. So here there is no place. So let's go to the next page quickly. So we got y of cos x is equal to 3 of x square minus pi square by 3. Okay. Now x is equal to pi by 6 we will put. So y into cos pi by 6, that is cos 30 degree, is equal to 3 pi square by 6 square, that is 36, minus pi square by 3. So this then this will be cancelled out, and finally you will be getting from here the value of y as minus pi square by 2 root 3. Okay. So according to it your option will be D. D option is correct. Is it clear? D is the correct. Good, Nishti. Okay, then let's go to the next part. Next question. D is the right answer. Solve the differential equation x plus 2y cube dy by dx is equal to y. Can you try this? I'm giving you 1 minute. Try this please and tell me what you are getting. Any idea how to do this? Yeah, tell me. Sorry. Mm-hmm. Okay. That. Hmm. I think in the last class also I gave you one of the method that instead of dy by dx they can give you dx by dy also, right? So yes, that this is the question from that only. Yeah. So x plus 2y cube into dy by dx is equal to y. We will take the dy by dx on the right side by taking the reciprocal, and we will be getting 2y cube upon y here. So by rearranging that, sorry, this is y. So by rearranging the terms, we can write dx by dy is equal to, separate them, right? Separate them. It will become x by y, and this will become 2y square. All right. So can you see? Can you see that this equation is nothing but in the same format, 1 by y into x is equal to 2y square. Look at this equation carefully, and you will be seeing that this is the same equation that we have discussed, but in the terms of dx by dy. So this time you can say the given equation is the first order is the first order linear differential equation in the form of you will be writing dx by dy plus p of y into x is equal to q of y. Okay, this is the same format but in the reverse direction, that is Instead of function of x, they will become the function of y now. So integrating factor will also change. So integrating factor value will become e to the power py into dy. Okay, and yes, the solution will also change. That is nothing but, this time instead of y into integrating factor, it will become x into integrating factor is equal to total integration of q of y into integrating factor into dy plus c. Okay, so that's it. You have to implement this part and you'll get the answer. So let's go to the next page quickly. So if I compare here directly, if you compare here, so can I say that py is nothing but minus 1 by y and qy is nothing but 2y square? Okay, so let's go to the next page. So now we can say the integrating factor, the value of that will be e to the power minus 1 by y into dy. And you know that the integration of 1 by y is nothing but ln y. So it will become e to the power minus of ln y. So, and when you take this negative sign inside the ln, it will become y to the power minus 1. So it will become finally e to the power ln of 1 by y. And ln is nothing but log base e. So when you apply the property of log, it will become simply nothing but 1 by y only. So the integrating factor that you are getting here is 1 by y. Okay. The simplest part is, if you are getting the ln in the integrating factor, then it is the easiest one, because ln means log natural and base is e. This base and this base is same, they are gone, and the answer is only the argument of the log function. Okay. So our solution will become, then we'll write here x into integrating factor, that is 1 by y, is equal to integration of q of y. Q of y was nothing but, let me check, 2y square, I guess, right? 2y square 2y square into 1 by y into dy plus c. This y and y is gone. One of the y and one of the y is gone. 2 will be taken as outside. Y dy plus c, and then we will be getting, it will become 2y square by 2 plus c, and this is x by y. So 2 and 2 is gone, and you can say that final equation is x by y is equal to y square plus c. Okay. So we can say that it will become simply nothing but x is equal to y into y square plus c, and that is our final answer for this question. So according to it, this fourth option is correct, D option. Okay, is that clear, or any doubt is there? Yes, D is the right answer. Okay, so let's go to the next part now. Now we'll understand. So this answer is D option. Now we'll understand one more question, and this question is basically based on the equation which are reducible to linear form. Equation which are reducible to the linear form. Okay, so let's try that. So actually directly you are looking at this question, you will not find this equation to be uh, first order linear differential equation. Okay, but we have to convert this. How we will convert this? You can see that sine y is there. We will take sine y as t. We'll take sine y as t. Okay, let's solve. Cos y dy by dx minus sine y upon x is equal to x square plus x cube. Okay, now we will take cos x as, just give me a second. So I'm saying that cos dy by dx minus sin dy by dx, this was a question. Now we are taking this sin y as t, and after taking the sin y as t, when you differentiate both sides with respect to x, we will be getting cos y dy by dx as dt by dx. So one variable will become now t and the other variable will become x. So therefore cos y dy by dx, this will be replaced by dt by dx minus sin y is taken as t upon x is equal to, it will remain as it is. Now can you see the direct equation? In one step you got the direct equation. Okay, and I think I told you about this also, ki they can use any variable, not only the y and x, they can use any variable. So in this case, what is the different variable? T. So this equation is in terms of x, and the variable y is taken as, or we can say the derivative of the t with respect to x has been taken in this part. So we'll be writing the given equation. The given equation is in the form of, is in the form of is in the form of dt by dx, or instead of this I'm writing in terms of t only, then p of x into t is equal to q of x. Okay, so integrating factor, then you will be finding out integrating will be nothing but, integrating factor will be nothing but px into dx only, the same thing. And the solution will be, instead of y you will be getting t here, then integrating factor t into integrating factor is equal to, then again q of x into integrating factor dx plus c. Okay, this will be the solution in terms of t. So let's quickly solve that and get the answer. Okay, this is not very difficult part. So we can say ki so from here we can say ki p of x is nothing but given as minus 1 by x, and q of x is equal to x square plus x cube. So quickly find out the integrating factor. That will become e to the power minus 1 by x into dx, and you know that whenever this minus and 1 by, so 1 by x integration is ln x. Okay, so e to the power negative of ln x. Okay, so whenever this 1 by x is given with negative sign, just just say that, or 1 by any function, let's say if any function is given like this, it should be linear, then you can take directly as fx, or we can say 1 by fx as the integrating factor. So here also when you will be doing that, it will become ln of x to the power minus 1, and which will eventually will become ln of 1 by x, or we can say simply 1 by x only. Okay, this thing will repeat so many times that it will get embedded in your mind. Okay, so integrating factor is 1 by x. Now just a solution, we'll write the solution here. The solution will be t into 1 by x is equal to, integrating factor is 1 by x, and the q of x is x square plus x cube into dx. Okay, you can introduce the constant here also, or after doing the integration also, that same thing. Now take this x common from this bracket. So when you take this, you will be getting x plus x square dx. Okay, one of the x is gone by taking the common from here, right? And in the left side you are already having t by x. Do the integration, you will be getting x square by 2 plus x cube by 3 plus c. Okay, plus c is also there, t by x. This is the final answer, or we can replace now the t value which we have written. So t is equal to sin y, we have put it. So sin y by x is equal to x square by 2 plus x cube by 3 plus c. This is our final answer. Have we done some mistake? T by x. It is correct, right? It is correct. So if you want, then you can multiply the x both side, and then it will be more modified, right? But it's up to you. Okay. So this is it. But one of the question we have discussed on the basis of this equation which is reducible to the linear differential equation. Now one more question we will do, and it has been asked in JEE mains also. So for this question, the answer is this one. They have multiplied the x here, you can see. Next question. They have asked this question in the JEE main 2020. So can you see the linear differential equation in this? Let me show you. E to the power y into dy by dx minus 1 is equal to e to the power x. Okay, it is already given ki if y is equal to yx is the solution of the differential equation. Means when you find out the y, you can equate this as to y of x also. So e to the power x, right? But is it directly convertible to the linear differential equation format, the way we have studied? I don't think so. Okay, because equation should be like this: dy by dx minus p of y is equal to q, or the reverse case. But if you see, even though if you take in the denominator like this, then you will write like, then you take this on the left side, it will become like this. Okay, which is not the correct format. With the dy by dx, it is not the correct format. So therefore, it will not work. So it means we must be knowing that here we have to do the substitution, or we can say, substitution exactly. Okay, so which kind of substitution we should do? Can we say, exactly, exactly. Ey we will take as t. Let's see what is the problem, then it will happen. Okay, so differentiating this with respect to x will become dy by e to the power y into dy by dx is equal to dt by dx. Okay, now just multiply this inside, so it will become e to the power y dy by dx minus e to the power y is equal to e to the power x. Now you can see this expression can be replaced by dt by dx, and e to the power y can be replaced by t. Okay, so is it the correct format? Okay, yeah, it will directly give the answer, right? So dt by dx minus t is equal to e to the power x format. In this case, we can say 1 is multiplied here. Okay, p is 1 here in this case. So we'll say the given equation is in the form of dt by dx minus p of x of t is equal to, plus, sorry, in standard format we are writing p of x into t is equal to q of x. So again, integrating factor value remains same, p of x into dx, and the solution. Instead of solution in this, y will not be written, t into integrating factor is equal to integration of integrating factor into q of x dx, and then you will be getting a c constant. Okay, so now just put it back and get your answers. Anyone got the answer? You can tell me. Acha, there they have given boundary conditions also, okay, right? So you have to find out the y of 1 also. So let's go to the next page. 4 is the right answer. Correct. Good. 4 is the right answer. So let's try to solve it quickly, and we have got it as dt by dx minus t is equal to e to the power x. So integrating factor we will be finding out. It will become e to the power minus 1 into dx, which will give us nothing but minus x, because integration of 1 is x only. So e to the power minus x is the integrating factor. Now the solution is t into e to the power minus x, that is the integrating factor, is equal to integration q of x. What was the function q of x? This is the q of x, right? You can see here in this equation. So e to the power x into e to the power minus x, it will become simple one. And when you, so they will be gone, right? Again, you will be getting here integration as x only and plus c. So t into e to the power minus x is equal to x plus c. And now we can replace the t value also, because the boundary conditions are given in terms of x and y. So we must replace the t in terms of y only. So t value will be replaced by e to the power y, which we have already assumed in the starting, is equal to x plus c. So this is our final equation we will be getting. Now put the boundary condition and get your answers. So the condition is given that at x is equal to 0, y is equal to 0. So it means e to the power 0 into e to the power minus 0, which will not make any sense. 1 is the answer. X is 0, c is 0. This is 1, this is 1. So c will be 1. Sorry. C will be 1. C is the answer. C is the 1. So now we will again put that back into the equation 1. So it will become x plus 1. Now the question is asking what is the value of y at x is equal to 1. So e to the power y we have to find out. E to the power minus 1 is equal to 1 plus 1. So it will become e to the power y is equal to 2 upon e to the power minus 1, which can be written as 2 to the power 2 into e to the power 1, or we can say simply 2e. Okay, is it fine? So e to the power y is equal to 2 into e to the power 1. When we take the anti-log on the both side, or sorry, not anti-log, we will take log on the both side. So log with base e, log with base e. So this will become what? Only y. This will become log of m into n. So log of m into n can be written as log of m plus log of n, and you will be getting this value as 1. So 1 plus log 2 base e. This is the final answer. 1 plus log 2 base e, fourth option. Okay. Now there is a similar kind of question. Next one. So for not first option. Okay, I think that is the mistake. This is D option. D option is correct. Now similar kind of question is given here. One more, which I am giving you to try. Okay. So this you can try at your home. Note it down quickly. The similar format is given. In this case, this is not reducible directly because it is the direct equation. You can take directly, separate that dy by dx from it, and you will get the direct equation. Okay, so when you write this, you will be getting dy by dx. Okay, this x dx will be going in the denominator, and it will go like this: y of yx square minus 3x to the power 4 upon x minus x cube, right? And then what we can do, we can separate them. Okay, we can separate them. So when you separate them, you will be getting some solution out of that, and that will be your answer. How to separate that? You can say uh, one of the separation you will do with the y. So y, you can take y into 1 plus x square, okay, minus 3x to the power 4, and this can be written as x into 1 minus x square. Okay, so you will do that and you will get the answer. So after that, separate them and take the coefficient of y on the left side. The same equation you will be getting. Boundary conditions are given. Find out the value. Right. So this is the homework. I'm giving the answer also. For this case, first option is correct. That is 12. 12 is the answer for this. Okay. Let's try this one. In this case also, it is not looking like directly the equation in the same format, because why? Let me tell you why. Can you see that this is y square ln x? However, if one student will think that, sir, if we divide the both side by x, then we will be getting y by x. Up to here, this is okay. But in this part, can you see the y is involved? However, we have discussed that that function should be totally in the terms of x only. So again, there is a problem in this part. So what we will do, we will try to convert, or we can say try to reduce this into the first order linear differential equation format that we have studied. So let's try that again. So in this case, what we will do, first of all, let me write this equation. First of all, we have to make this q function free of y. So what should we do? Divide by y square on the both side. So first task will be divide by y square on both side. So when you do that, you will be getting in the left side as x by y square into dy by dx, plus y upon y square, you will be getting 1 by y only, and in the right side you will be getting simply ln x. Now still this equation is not in that format which we want, but now this is this is what we can reduce to the given for reduce to the our required format. Okay, how will we reduce? In this case, we will take 1 by y as t. By substitution, we will reduce, of course. So 1 by y will be taken as t. And you know that when you differentiate both sides, it will become minus 1 by y square into dy by dx is equal to dt by dx. So minus sign can be taken on the right side, and you will be getting 1 by y square into dy by dx is equal to minus dt by dx. Okay. So now just replace that values. Okay. So when we replace this, so x will be remain as it is, and this value will be replaced. See, 1 by y square into dy by dx. This will be replaced by minus dt by dx, plus 1 by y will be t, and rest of the thing remains as it is. So we got minus x times of dt by dx plus t is equal to ln x. We can multiply the negative sign on the both side and divide by x also, divide by x, or we can say divide by minus x on the both side, right? So it will become dt by dx minus t by x is equal to negative sign of ln x upon x. Now can you see that that is the same format we wanted? Okay, in terms of t only. So now again we will find out the integrating factor for this. So what is the integrating factor for this? We will be getting integrating factor will be e to the power p dx. P dx means it is given as 1 minus 1 by x into dx, and I told you that if it is minus 1 by x is given, the answer is directly 1 by x. Okay, when you do the integration, it will become same thing, because 1 by x integration is ln x, ln is having the base e, minus 1 will be taken on the power of the x in the argument, and finally you will be getting the integrating factor as 1 by x only. So now let's write the solution then finally. So the solution will be t into 1 by x is equal to integration of, what was the left value, sorry, right value, minus ln x upon x, right? So the qx function is ln x upon x with the negative sign I am taking outside into integrating factor, that is 1 by x. Okay, now what should we do? We have to of course integrate it, right? So it is t by x is equal to is equal to we can say minus ln x Substitution, I think substitution we can do here, right? Yes or no? But 1 by x square is given, right? Yeah. Exactly, exactly. Same thing we have to do. So if we take, correct, correct, correct. I think that method was written correctly. That format was written correctly. We can write this in this format only, ln x by x, so that I can get the its derivative also. So when you take this ln x as not t is already there, so you should take another variable, let's say u. So 1 by x into dx will become du. Okay, 1 by x into dx will become du. But it is 1 by x square, right? Hmm. X we can take x to the power e to the power u. X we can take, right? So this is dx is already also there here, right? So means this value will be replaced by e to the power u, and ln x can be written as u. Yes, 1 by minus. Okay, now it is fine, and du. Now I think it is fine. So 1 by x we have taken e to the power minus u, and ln x we have taken already u. So it is simply nothing but by parts we can use, right? So when you use that by parts, I'm just giving you the right direct answer, the final. After replacing the u value also, you will be getting 1 by x into ln x plus 1 by x plus c. And t value we have assumed, right? The t value we have assumed was 1 by y. So it will become 1 by y, so it means 1 by xy. So final solution from here, you can take the LCM, 1 by xy, or let's remove the x from the both of them. So simply multiply the x, multiply by x. So when you do the multiplication, you will be getting 1 by y is equal to ln x plus 1 plus cx, and then simply take the reciprocal, because y we have to find out. So 1 upon ln x plus 1 plus cx. So accordingly you can choose your option. I think it is okay. They have taken this like this: y into ln x plus 1 plus cx is equal to 1. So this is the answer, C option. Okay, is this clear? Now the next topic, Bernoulli trials. Okay, actually Bernoulli equation is also a type of equation which is which helps us to convert uh, convert to the linear form. Basically, it is also kind of reducible to the linear differential equation. Yeah. Okay. So let's go to the next part. This was the answer. Again, I think there is a wrong question, wrong answer given. C is the right answer. C. Next is a Bernoulli equation. Okay. Up to what we have discussed before this Bernoulli equation, your board syllabus is over already for this chapter. Okay. From now onwards, there are some extra topics that has been involved in the JEE mains we have to discuss. So Bernoulli equation, let me change the color. So Bernoulli equation tells that the equation will be in this format. That is, y will have some sort of powers. So dy by dx, p of x y is equal to q of x into y n. We have already discussed one question previously. Okay. So what we will do, first of all, we will make this q of x free from y. And in order to do that, what we will do, we will divide this by y to the power n. we have did the same thing. Okay, so when you do that, after that we have to replace this value by another variable, and that can be done if we put 1 by y to the power n minus 1 as t, or 1 minus n as t. Okay, so when you take this as t, after doing the differentiation on the both side with respect to x, we will be getting that 1 by y to the power n dy by dx can be replaced by 1 by 1 minus n dt by dx. Now the n can be anything, right? N can be 5, 4, 3, like that. 0, if it is 0, then it is easy, right? So it is already said that n cannot be 0 and 1. The 1 and 0 is not means is not applicable in this part. All right. So let's understand one question on this. Yes. So this has been asked in 2011. So the question saying that solution of the differential equation cos x into dy is equal to y of sin x minus y dx. Okay. First of all, we have to try to convert this equation into the dy by dx format. Okay. So let's say कि cos x dy is equal to y into sin x minus y into dx. Right. So we will write like this: cos of x into dy by dx. Okay. Take the dx on the denominator in the left side, and in the right side you will be getting y sin x minus y square. Okay. Now if we take cos x into dy by dx as it is, and take the y sin x on the left side, y sin x on the left side, on the right side you will be getting minus y square. Now can you see that this is the exact same format which we have discussed just now in the Bernoulli equation? Right side should be the function of x, since it is a dy by dx function, right? So right side should be a function of x only, but here instead of that y square is given. So we have to free that from this, right? And dy by dx is also given with the cos x function. Okay. So what we will do, instead of just by dividing the y square only, we will divide this by cos x into y square with a negative sign. That will make our question easy, or more easily solvable. Okay. So divide. Now we will be saying divide by minus cos x into y square both side. And when you do that, in the left side, if you can see, you will be getting minus 1 by y square into dy by dx, because cos x and cos x is gone. Then negative and negative is gone, and y will be multiplied. Sin x upon cos x will become so sin x by cos x will become 10x. So with the positive sign, this is 10x, and the coefficient of this will become 1 by y is equal to, on the right side when you divide by minus y square, 1, but upon cos x is also there, it will become sec x. Okay, that is a simple division. If you do that, you will be getting this expression. So now we have converted this into this format, but now again this is not the linear differential equation what we have discussed. The format of dy by dx plus p of x y is equal to q of x. So again this is reducible to the differential equation. So what we will do, we will take the substitution, or we will do the substitution. So now what can be the substitution? So we say that let 1 by y as t, okay, this part has been taken as t, then minus 1 by y square into dy by dx, means differentiating on the both side with respect to x, will give you dt by dx. Okay, just replace this in this equation 1, let's say. When you replace this in this equation, you will be getting dt by dx and then 1 by as taken as t, so it means plus 10x into t is equal to, it will remain as it is sec x. This is our final equation we got, and now you very well know how to solve this. Take the integrating factor, find the integrating factor, and get your answers. So let's write the equation again. So we got the dx dt by dx and plus 10x into t is equal to sec x. So you can say that given equation is LDE, linear differential equation of the form of dt by dx plus p of x into t is equal to q of x. Right? Now find out the integrating factor for this part. So integrating factor will be e to the power 10x into dx, and we very well know that the integration of 10x will become ln of sec x. So e to the power ln of sec x, and the answer is directly nothing but sec x only, because ln means base is e. So the solution will become t into integrating factor, that is sec x, is equal to integration of uh, sec x, that is a q of x function, into integrating factor, that is again sec x, into dx. And you know that this is sec square x dx, and integration of sec square x gives you nothing but 10x and plus c. So t into sec of x is equal to 10x plus c, and if you find out, okay, let's put the value of t also. T we have assumed 1 by y, so sec x upon y is equal to 10x plus c. So you can find out the value for 5 from here, or you can multiply the y because sec x equation is given. So sec x is equal to y into 10x plus c. That is our final equation. Okay, is that clear, or any doubt is there? Anyone? D option is correct. Right? Okay. Note it down if you have not done yet. Good. Let's go to the next part. So D is the right answer for this case. Now this question I am again giving you the homework. You can try this. Okay. And the similar thing is given. You can see 1 plus e to the x into e to the power y into e to the power x. So you can try this. You can just convert this e to the power y upon e to the power x like this, and then take them into the left side, and try to convert them into the linear differential equation. Okay, you will be getting a point in which you have to take this e to the power minus y as t, and then further solve. All right. So this is I am leaving up to you. All right, and you will get the answer options I am giving you. The B option is correct. Okay, which is this one. Take that option, this option. 1 minus root 3 minus log base e root 3 minus 1. All right, so now let's go to the next portion, orthogonal trajectory. Okay, so basically orthogonal trajectory is saying that we have to find out the equation of a curve, or we can say equation of a family of curve, when a different curve, or when the other curve is basically intersecting the given curve on the perpendicular, or we can say at the right angle. So what we say, a curve which cuts every member of a given family of curve at right angle is called an orthogonal trajectory of that family, of the family. Now how to find out this orthogonal trajectory? Suppose that if a equation is given which is f of x comma y comma c is equal to 0. Okay, the equation can be given in terms of y, x as and c also constant, which is the family of equation, and c is the arbitrary constant. The first step is this one. Second step, you will be saying ki after finding out find the differential equation first of all. Okay, you have to find out the differential equation for this, and then substitute the dy by dx by minus dx by dy. Okay, it is the same thing what we discussed. Let me tell you here. Do you remember that for any curve how we were finding out the slope for any slope of tangent? So dy by dx was giving you the slope of tangent, right? Now how to find out the slope of normal from this? It will become minus dx by dy. It is the same thing. It is the same thing, you can see. So in order to find out the curve which is perpendicular to the given curve, is actually you are finding out the curve which is passing through the normal of that. Okay, that we call it as a orthogonal trajectories. So we will get after replacing this, we will get a differential equation of orthogonal trajectories, and now solve that differential equation and you will get the equation of the curve. Alright, so it is like a reverse procedure. Don't worry, we will understand from a question. So we have a question here, and one more thing, note point is that if orthogonal trajectories from the same family of curves as the given family of curves is given, then the given system of curve will be called as self orthogonal. Suppose if the given suppose that the family of curve is given to you as a circle, okay, and the orthogonal trajectories is also coming as the circle, then this will be called as self orthogonal, like this. Okay, let's understand a question. Simple question is given here. So you can see we have to find out the orthogonal trajectory of these circles. It is an equation of circle, of course. X square plus y square minus ay is equal to 0. And then what is it asking? To find out the orthogonal trajectory. So just first of all we will find out the differential equation. Okay, how? By differentiating it simply. By differentiating it with respect to x. When you do that, it will become 2x. It will become 2y into dy by dx minus a into dy by dx is equal to 0. Now from here you can say that dy by dx can be taken as common. So we will be getting 2x plus dy by dx as taken as common into 2y minus a is equal to 0. Now if you remember the steps initially what I have given how to find out the differential equation of any curve given, we have to remove that arbitrary constant. How do we remove that arbitrary constant? From this equation. This is the first equation. So from the first equation we will remove the arbitrary constant, and then we will put that arbitrary constant value in the equation second. This is the equation second. So from here when you find out the a value, it will become x square plus y square by y. We can put this value in this equation 2. So it will become 2x into dy by dx into 2y minus a value is x square plus y square upon y is equal to 0. So this is what we got. We got the differential equation of the circle. Differential equation of the circle. Circles. But is it the orthogonal trajectory? No. In order to do the orthogonal trajectory, what we will do, you will have to replace the dy by dx by minus dx by dy. So therefore the equation of orthogonal trajectory will be by replacing dy by dx by minus dx by dy. Okay, do that and you will get another differential equation. Okay, let's write that. We will be getting 2 of x minus dx by dy into, and when you solve that bracket part, you will be getting y square what was it? Let me see. It was 2y. So when you take the LCM, 2y square minus x square plus y square, it will become x square and plus y square by, sorry, minus x square plus y square, or I can say y square minus x square upon y, okay, equal to 0. Now this is the another differential equation you have got. Okay, let's write this in the other format, like if you see that if I write this dx by dy value equated, so we will be getting what? 2xy upon y square minus x square. So can you see that we don't need to solve by linear differential equation? It is the simple homogeneous form. It is a simple homogeneous form, and if it is the simplest homogeneous form, then we have to just put the value of y as vx. Okay. uh, Actually it should be dy by, have we done some mistake? Exactly, so we can reciprocate it exactly. So we'll be getting y square minus x square upon 2xy, simple. Okay, so now just the method you already know. What we will do, we will put this y is equal to vx and then differentiate both sides with respect to x. So dy by dx will become v plus x d v by dx, and then replace this value and solve. Okay, so I think you can do after this. And when you solve this further, finally integrate that, you will be getting the equation of the circle again, which is nothing but the b option. Okay, will you able to do that? Yes or no? So I'm writing the equation, last equation you'll be getting 2v upon 1 plus v square in terms of v, dv is equal to 0. Okay, this is the equation you will be getting, and then you have to do the integration, right? Okay, so this is how you'll be doing this. Now let's go to the last topic of today's session. This is the answer, b option you'll be getting. B, no? Yes, b is the right answer. The last is application of first order differential equation. Now the application of this can be in terms of temperature problems, like the Newton's law of cooling. You know that the Newton's law of cooling, what it says, that if I think it is not written fully here. This is this one. Yeah, this is correct. So Newton's law of cooling says that, okay, this is the not Newton's law of cooling. This is the growth decay problems, right? So in this is the growth decay problem. We are saying that n is basically the, let's say, population. Okay, n is the population for a particular month, and dn by dt is basically nothing but the change, or we can say rate of change of this population per year, or rate of change of this substance per year, right? For the substance also we can use, just like in chemistry you use, right? Or population also you can use. That's why it is known as growth decay problem. Either it can be used for the chemistry, or either it can be used for the populations also. So what we say that the rate of change of the population, or the substance, is directly proportional to the quantity, or we can say amount of substance initially given. So in order to replace that, we will replace this, in order to replace this proportionality sign, we will replace this with a constant k, and that's how we'll be getting a equation here, right? Similar thing will happen with the Newton's law of cooling, that says that dt by t, that is the rate of temperature, is nothing but actually T1 minus T naught. T naught is the initial temperature, T1 is the final temperature of a body, and this is saying that uh, how the rate of change varies. Basically, the rate of change varies in this case according to their difference of temperature. All right, rate of cooling, rate of heating, it can be Newton's law of cooling, you can connect with it. So this is the application also used in the differential equation, and there's a question. It is an important one. This is the question that has been asked in JEE mains the this year only. Okay, so what is it? It is saying that temperature of a body T of a body at time t is equal to 0. Yes. Okay, at time t is equal to 0 is given. It means they are giving you T0. T0, as I said, that initial temperature of a body, right? And it decreases continuously as per the differential equation. So they have also said that the temperature is continuously decreasing as per this differential equation, where k is the positive constant and t of 15 means what? They are saying ki at t is equal to 15 second, the temperature is 120 degree. So find t value at small t, that is time 45 second. Means they are asking you the middle values. Okay, they are not asking you the end values, they are asking you the middle values. So it is related to the differential equation only, again you can see. So this is our first equation. Okay, this is our first equation, and can we say ki this is the simply nothing but the variable separable format. This is simply nothing but the variable separable format, and then we can do the, sorry, this is k dt. Then we can do the integration in the both side. So when you do the integration on the both side, you will be getting dt upon t minus 80 is equal to minus k times of dt. Okay, you can see the linear format is there in the denominator. And one more thing, that limit will also be used, right? Limits will also be used. What is the limit? Because we say that limit is from the lower limit to the upper limit. Lower limit will be taken at time t is equal to 0, which is nothing but 160 degree Fahrenheit. So 160 degree, all the temperatures are given in the Fahrenheit only, right? So we don't have to worry about. So 160 degree, and the final temperature we don't know. So we will take T, let's say. So in this case, first of all, you will find out the equation of the cooling actually, and then we have to find out the whatever it is asking. So the ln of T minus 80 with the limits 160 degree 160 Fahrenheit to the T and minus KT plus C. So when you replace the value upper limit, when you put the upper limit, it will become ln of T minus 80 minus ln of 160 minus 80 is equal to minus KT plus C. So can we say that we will be getting here T minus 80 minus ln of 80 is equal to minus KT plus C. Okay, let me write on the next page. So you will be getting ln of T minus 80 minus ln of 80 is equal to minus KT. Right? So now what we will do? So yeah. So this is what ln A minus ln M minus ln M. So we can say na ki this ln of it will become M by N. So ln T minus 80 upon 80 is equal to minus KT, and that's how we will be getting T minus 80. Take the antilog on the both side. T minus 80 upon 80 is equal to e to the power minus KT. And finally, if you find out the T value only from here, so 80 will be multiplied to this 80 into 8 to the power minus KT plus 80. So this is our final equation you are getting. Okay, and now the conditions are given. So they are saying that at T is equal to 15 second, the temperature is given as 120 degree Fahrenheit. So let's put in this equation 1. So it will become 120 is equal to 80 into e to the power minus k into 15 plus 80. Okay, 120 minus 80 will become 40. 40 divided by 80 will become 1 by 2. So can I say you will be getting from here e to the power minus k into 15 is equal to 1 by 2? Just use this directly, okay? Don't have to solve. We don't have to solve it. Why? Because we will directly write the equation in terms in this term only. So t will be equal to t will be equal to uh, hmm, t will be equal to 80 plus 80 into e to the power minus k t. K instead of k we will be sorry, instead of t we will be writing 15t. We missed something. Have we missed something? Someone was saying something. E to the power 15. Hmm, correct. So our new equation will become na in terms of 15 only. That's okay. I'm just saying कि our new equation will become in terms of minus 15k. Uh, all right. Is this correct? No, just see carefully. Yes, yes, just see carefully. What I have done, instead of e to the power minus kt, I am putting the t value as 15. Okay, so it means you are getting it here as this is nothing but t of you can say uh, e to the power minus k, something like that, function like that. Okay, so what I'm saying ki if you want to find out the at 45 degree, at t is equal to 45 degree, so what you will say ki we can directly put this as t is equal to 80 plus 80 into e to the power minus 45 k. It will be like this. So instead of writing 45 we can write this as 15 into 3, or 15 yeah, 15 into 3, right? So that means we can say that t is equal to 80 plus 80 into e to the power uh, minus k into 15 and whole to the power 3. 15 into 3 will become 45. Is that clear? Okay, so we can say 80 plus 80 into e to the power minus k into 15 and whole to the power cube. That is basically 3 is multiplied to the 15 only. Now what is this value? This value we already know. What is 1 by 2 from this equation, second equation? So that's what I'm saying ki we can directly use that value. So when you use that value, it will become 80 plus 80 into 1 by 2 whole cube, which is nothing but 80 plus 80 by 8, that is 10, and the final answer is 90 degree Fahrenheit. Is that clear? So actually there is a catch here, that is what we are doing. We can directly use this t of 45. Actually this is t of 45 only, right? This is I'm writing t of 45 only. So instead of if you're writing 45, there is no constant is involved, right? There is no constant is involved. So therefore what we can see, t value can be replaced by 45, and that 45 can be written as 15 into 3, that is e to the power minus k into 15 whole into 3. So e to the power minus k into 15 is already we have solved, which is nothing but 1 by 2. Put that value directly there and solve it, you'll get the 90 answer. Okay, I hope that now it is clear. So with this, now we have reached to the end. This is the answer, C option. And I hope that you all enjoyed it. So thank you. And now we can wrap the session.